Hello children. Now I am ready for the next topic of the capacitor, class 12th, that is the energy stored in a capacitor and energy density. Energy stored in a capacitor means when we are charging a capacitor, then definitely certain amount of energy is stored in it which can be utilized later. So now how much energy is stored, that can be determined by using a simple derivation that I am taking right now. So let's go to the topic. Yes, this is the derivation for the energy stored in a capacitor. Normally we know the energy stored will be is equal to always work done. So we can start from the formula, that means energy stored will be is equal to Q into dV, because Q dV is representing that equal to the work done. So to determine the value of energy, we can integrate the right side here. In this case, we can see the Q is not a constant quantity because charge and potential are correlated to each other. As we are charging the capacitor, potential changes. That means the potential depends on charge. So we need to write this Q in terms of some constant terms. So we have written it here. Q is equal to CV and dV. So C is constant, so it can be taken out of the integration. So what we got, that is V dV. When we are integrating, we are getting this is equal to V square upon 2. And finally U is equal to half CV square. That is the formula for the energy. We can write the value of C as Q upon V. So we can get another formula for the energy, that is U is equal to half QV. And if we are writing V in terms of C, that is Q upon C, so we can get this formula as per the required conditions. Now, next derivation is for the energy density. What is energy density? Energy density is basically the energy stored in a capacitor per unit volume. When we are determining the energy stored per unit volume, what is the volume of the capacitor? Volume of the capacitor is basically simply defined as the area of parallel plate multiplied by the distance between the plates. You can see, we can understand by a diagram, that is, this is a capacitor and this is the distance between the plates. Suppose that is D and area of plate is A. What will be the volume? That means this area multiplied by this distance, this will be represented as the volume of the capacitor. How can we write it? Dekho. Energy density is represented by a symbol del U bar, small u bar. This is equal to U upon volume. Here I have written the complete statement volume, not V, because V is representing the potential here. So we can write it, this is U upon A into D. This is the volume of the capacitor. Value of energy we can write, formula we have derived right now, half CV square upon AD. Here we have taken half out here, and the value of C is epsilon naught A upon D, and potential can be defined as electric field multiplied by the distance between the plates, and if it is a square, we have written here square. Now upon AD is already there, so I have written as it is. Now we can see this is epsilon naught A, E square, this is D square upon A, and this D will come here and multiply will make it D square. Now you can see this A and A will be cancelled out, this D square and D square will be cancelled out, and final formula for the energy density will be U bar is equal to half epsilon naught E square. That is our final formula for the energy density. So these are small derivations which we can try easily. Thank you.